Hello everyone, welcome to another video of SlideScope where we are discussing about exploratory analysis and forecast of solar power plant, and for this we are using data of a power plant. So you can see we have two files, which is one file is for generation data and one file is for weather sensor data. For beginners, we have prepared some graphs here for plant number 1. Here you can see AC power and DC power generated per day. Here you can see power generated versus time. Here you can see comparison of our data with the standard data, which we will discuss in a bit. Detail of daily power generated, daily DC power generated, and inverter efficiency graph, which we can see from this particular website eeducation.tsu.edu, that this is efficiency curve. In our case, it's looking something like this. Obviously we have some outliers here, but more or less it is looking like this. So the data that we have is of two power plants. We have got this data from this data set, solar power plant data set, and it is on Kaggle website. Here we have data of two power plant, plant 1 generation and weather data, plant 2 generation and weather sensor data. So whatever we have done here, we will try to create the same thing here. And for example, in this case, you can see power generated versus time. You can see the standard data, right? The shape of sunlight's effectiveness on your panels is determined by the angle of sun. So for example, here you can see from 6 a.m. to 6 p.m. power is generated by a solar panel, and you can see that the solar output as compared to percentage of array rating, so it is at 20%, 40%, 60%, 80% around 12 p.m. time, when the intensity of sun is mostly there, and as the intensity declines, you can see that solar output percentage also getting declined. And this is the standard curve. In our case also, you can see that starting from 6 p.m. to 6 a.m. to 6 p.m. how the plant in this case is performing, and this is for all day. So this is the summarized data, but when we select for a particular day, you can see that there are fluctuations in every day's output, okay, because it depends on too many conditions, right? For example, the greater atmospheric difference, the more energy absorption occurs, leaving less available for your panels to convert into electricity. At midday, when the sun is directly overhead, sunlight encounters fewer atmospheric layers and allowing your panels to absorb more sunlight during this period. Same during winter, the same principle holds true. However, on overcast winter days, there might be a reduced amount of sunlight available for your panels to capture. This can be attributed to the sun being positioned lower in the sky compared to its height during summer. So depends upon various factors. And we also have the weather data here, right? So you can see we have ambient temperature and irradiation. So what is all this, we will discuss just uh, when we will create the same graph for the second power plant. So first of all, in order to get it started, we will open Tableau public here, and in Tableau public we will connect the data. Here you can see our data is in two files. plant 1 generation data, plant 1 weather sensor data, plant 2 generation data, and plant 2 weather sensor data. Remember, this particular solar power analysis is going to be a series of data. So a series of analysis. So in this part, we'll just do some exploratory analysis. And now we will connect this data with Tableau. So here you can see we have clicked on the text file here, and we will select any one of them. This plant 2 generation data and plant 2 weather sensor data are actually of the same power plant, and in this file you can see there is plant ID, and hence we can connect these two files. We can create a relationship between them. Although Tableau is not able to understand the relation, so we have to tell that plant ID in the first column is equal to plant ID in the second table. In the first table, it is equal to plant ID in the second table. So now for weather sensor data, we have date time value, like for a particular day, as you saw here, right? For a particular day, when the when it operates, so data of complete 24 hours is there. So that's why it is very important to keep it in date time format, right? And now both these tables are joined, or in this case related, and then we will go to sheet to start analyzing the data. So this is AC power generated and this is DC power generated. Solar power plants usually generate DC power, and then with the help of inverter it is converted to AC power. So first of all, if you have to analyze this type of data, so you can just drag date and time here, and when you drag date and time here, you will see two types of dates here, right? One is a dimension based date, like what Tableau does is it has dimensions and measures. Okay, dimensions is a qualitative data and measures is a quantitative data. So when you see green values, this is quantitative data. When you see blue values, this is qualitative data. So here, suppose when we drag any date, by default it will summarize it and it will start showing year. So year, quarter, month, day and more is there. So what this will do is this will show the data as a summary. Like for example, in this case we have 34 days of data. Okay, so we read the data description, we have data of approximately 34 days. So when we will select day, it will summarize 1 to 31 only, because in a month there is a maximum of 31 days. So it is giving us some kind of summary. Similarly, if you will select month, it will give you 2 months only. Okay, so this is how this particular dimension date works. Then we have this measure also. Here if you will select, you will see the exact date, like starting with 15th May going to 17th June 2020. So you have to keep this date. Okay, you have to keep data of date, and suppose you want to compare, like what is the total amount of AC power generated in power plant 2 as compared to DC power. So AC power and DC power per day, generated per day, and here the power is given, which you can see here, and you will see the sum of AC power. So for every day the total AC power generated. Okay, now suppose we have to include DC power here in the graph. So there are various ways of including another measure here, right? Because we connected two tables, so we can see these two tables here, and when we have to drag another variable on the same scale, okay, because for every day with respect to some DC power, some AC power is generated. So when you will drag DC power in rows, you will see a data like this, which is good to compare. You can see it is almost similar because obviously these two are correlated. These two are directly proportional. But here the comparison in terms of scale is very difficult. Okay. So what we can do is when we have to compare something like this, so we can drag them on the same axis because power is generated and calculated in watts, the unit of power, watt, kilowatt, megawatt, this is unit of power. So here the AC power and DC power have the same unit, so that's why we can drag DC power on the same scale here, and then you can see, right? So let me drag this once again. There is AC power and there is DC power. You can see a very little difference between AC power and DC power because the efficiency of this plant is very high. On the other hand, when we compared the same thing in plant number 1, you can see how low the efficiency is. So efficiency of this plant is, this inverter is very low, right? But here you can see efficiency is quite high because these two graphs are very much their values are almost equal to each other, and we will calculate the efficiency also with the help of calculated field. So this is AC power and DC power per day. Now how can we calculate efficiency? Okay, so for that we have to look at the formula, and formula is you have to divide the powers generated, and because from DC AC is created, right? So that's why you will see that DC power is always more than, will always be more than AC power because there will be some loss in the device. So that's why in order to create or calculate the efficiency, just click on this small arrow here and create calculated fee. We'll call it efficiency. Okay, create a bracket here, drag AC power, use forward slash operator which is division operator, DC power. So this is how you can create a calculated field and then multiply it by 100 because efficiency is given in percentage. So that's why we are doing this, and apply and OK. Okay, so this will give us efficiency, and if you will drag it here, this is actually sum of efficiency, which is, it doesn't make sense. So let's do average efficiency, and this is the exact average efficiency. The efficiency in this case is 97.68%, and we can go and create it into a text table, and we can simply call it efficiency. Later when we will create a dashboard, so this particular value can be used as a card. Okay, these single values can be used as a card. So this is our efficiency, and we can actually format it, and we can go to sheet and increase its font size, make it bold so that it's clearly visible. So now we have AC power versus DC power. You can see a very small little difference here. Then the efficiency. So this is what we have created and calculated so far. Now the other most important thing is we have to generate power generated versus time, which you can see here, right? power generated versus the time. So for this, what we have to do is, obviously we can see that in a day there are 24 hours obviously, and every day the graph is different, right? It starts at 6 a.m. when sun rises, goes up to its peak at around 11 or 12 p.m. and then it starts going down, and when the sun sets you can see there is no power generated. So how can we create a graph like this? The whole purpose of this particular tutorial is to teach students perform analysis on real data, and in the meanwhile we have to teach them also for what type of data you have to draw what type of graph. For example, here we can choose bar graph also, okay, but line graph is actually a better graph here, because I have told in our previous lectures also that when time is on x-axis and there is a measure on the y-axis, a continuous measure, so you always have to draw a line graph, because when you have to see power generated compared to time, so with the help of line graph it will be best to tell, right? And that's why you will be able to compare it with the standard graphs. So power generated with respect to time, we can take DC power or AC power, whatever you want. You can see they are almost similar, 97% efficiency. So here is sum of DC power, okay, and here is date and time. You will see a dot here because it is showing you year, okay. You can drill down here, drill more, but you don't want to do this because this is data of just 34 days, okay. So what you have to do here is, because this is data of hourly basis, right, you go to more and select R, you will see this, okay. Here is also R. So here what is happening is, starting from day 1 going up to last day, this is actually the same graph, okay, but this is for every day, and as I said, this is quantitative, right? But as a dimension, when you will select R, this will show you as a summary, like for every day on an average what is the data, right? And if you compare it with the curve, the standard curve that we have, this curve, okay, you will see that in this case it is actually not, representing that bell, the inverse bell thing, okay? So but in this case, if you select as a whole, you will see it is almost like a bell curve. You can see that performance of plants, differ under different conditions, and obviously there are conditions like ambient temperature, irradiation and all. So irradiation or irradiance is the power of solar radiation per unit area measured in watt per meter square. Solar irradiation is the quantity that measures the energy per unit area of incident solar radiation on a surface. You know that solar panels have a surface. So you can see we have created this image. It was created earlier by us to explain how solar panels work. So here you can see so many advertisements. Let's open image without any disturbance. Yeah. So you can see that in a solar panel, you can see we have negative electrons, positive holes. Obviously, you don't have to go with the working. The simple concept is there are photovoltaic cells in solar panel. Photovoltaic, that means when photo means light in this case, simply photo or photons, right? When light falls on the surface of a PV cell, it generates some voltage. Okay, simply. So that's why it is given here, and that is what irradiation is like. Solar irradiation is a quantity that measures the energy per unit area of incident solar radiation on a surface, on any surface. Okay. So now let's go back to our analysis. Now suppose this is obviously DC power generated per hour, so we will rename it as DC power generated per hour, and suppose we have to see the variation on every day. Okay, so what we can do is we can drag date and time in the filters, and we can select range of date and click next, and you will see range of dates, right? You can either select range of dates, or we can also select month, day, year, because we have to filter for every date. Okay, so in such cases we can select month, day, year. So you will see all the unique dates here. Select all of them, apply. Okay, and then show filter. If you will show filter, it will appear like this. Currently it's a checkbox, so you can select 1, 2, 3, whatever. But if you want, you can also select single value drop down. Okay, this way you will be able to select only one day. Okay, you can also select single value list, so you will be able to see list and bullets. Now here you can see on 20th May 2020 we have so many fluctuations. Okay, as you can see on 20th May 2020 at 12 p.m. at which we usually have a peak, we have valleys over here, right? The power generated is not as it should be. So for that we have the second table, right? Now we will try to analyze something similar. We'll analyze ambient temperature and irradiation for the same day, and try to analyze what is happening here, right? What happened on this day. So for that, again, you just drag date and time, and here we have to select. Sorry, here we have to select the hour, which is the summary, obviously, and then let's select ambient temperature. Okay, so this is how weather was on this day, and for ambient temperature we don't want to select sum, we have to select the average. So instead of sum, what I just did is I used the function avg, because then you will be able to see 25 degrees, 24 degrees. You can see obviously 11, 12, 13, 14, and at these hours temperature is more in this particular power plant on these particular dates, and you can see here it is lower at 6 a.m. right? It starts increasing and then decreases. So now what we have to do is we have to again drag date and time in filters, do the same thing, because we want to see what was happening on that particular time, on that particular day. Now show filter, drag single value drop down, or let's say list, and here we are analyzing what happened on 20th May. Okay, So on 20th May you can see at 12 p.m. we did not have peak at 12 p.m. right, we actually had a peak at 3 p.m. So, and you can see that obviously the day started it should, and that's why we have this information. Okay, and we will rename it as ambient temperature per day, and we can copy this, duplicate, and instead of average ambient temperature we can select module temperature. Module temperature is the temperature of solar module, right? Because with the help of sensors we can tell this data, and on the same day you can see module temperature was very high. Obviously we have to select average here as well. So module temperature was very high at these times. We can duplicate, we can rename all of this. So this is module temperature per day, and then here we'll just replace it with irradiation. Obviously we can put all of them together also, but we are not doing that. This is sum of irradiation. So here you can see that we actually have peaks at this time, which is causing this type of data. And similarly you can see for other days this same, it is not so much weird for other days. Obviously here you can see we have very low here, low power generated here. So this way you can actually create more graphs like this. You can try to analyze what is happening there, and you can compare 2 or 3 different variables. You can look for different type of situations. Finally, for exploratory analysis, we will try to create inverter efficiency graph, and in order to create inverter efficiency graph, what we will do here is, because DC power is something that is independent here, right? DC power is generated, and with DC power AC power is generated. So you have to go with the concept of efficiency curve. So you have to go with the concept of what to put on x-axis, what to put on y-axis. So let's select DC power on x-axis here. Okay, x-axis, AC power on y-axis, and you see a dot. This is because Tableau by default will summarize your data. Go to analysis and mark this as unsummarized, right? So here you can see that obviously we'll see a straight line kind of thing because it is almost 97%. But we'll keep DC power as a filter and keep 1 here. We have to select only those cases where DC power is more than 1. That means we want to select, we don't want to select these R's basically. So now AC power is there, and then we will drag efficiency, our calculated field. So let's drag it like this and this. Okay. So now you are seeing a curve here, which is not looking anything like the curve that we saw here, because here what you have to do is from here 0 to 90. Okay, what we have to do is we have to edit the axis and uncheck include 0. And now it is looking somewhat closer to that curve. So this is what we were analyzing, and obviously you can go to filter and take some particular amount, like let's say 406. Okay, so you can analyze it for different such values. So this is a simple exploratory data analysis on solar power plant data. I will provide link to these because this is a Tableau public. So I will provide links to these Tableau public files. So which will be on Tableau public server. From there you can create an account on Tableau public and you can edit these things. You can edit these sheets. In the next part of this video, we'll update more related to this particular chapter. We'll focus on forecasting values, which usually works like something like this, like you can forecast here. So we'll work on more such cases. So please subscribe to our channel for more videos related to Tableau, more videos related to data analysis and business intelligence. Thanks for watching. Have a nice day.